Hi, Sarah.
Hi
It's good.
Esther, how are you doing?
I'm fine. How are you doing as well?
I'm doing
I'm just
great,
trying
thank
to
you.
wrap up the other session. Please give me a minute.
Oh, okay, that's fine.
All right, I'm here. Okay, can you hear me?
Yeah, I can.
Okay. All right. So, first, I would like to see if you can share your screen. Can you try
Yeah,
sharing?
I'm actually working on that now.
All right.
Okay, please give me a minute. Okay, so I'm getting host disabled participants screen sharing.
So let me make you a co-host. A co-host. Yes.
Okay,
All right. So I just made you a co-host. So you can try now.
okay. I'm coming. I think I can share. So just a minute, please. Okay, I'm coming. Okay, can you see it? Can you
I'm
see my
coming.
screen?
Yes, I can see your screen.
Okay, so what's next?
We're just going to wait till 1:50 p.m. so we can get started.
Okay, so I'd love to stop sharing for now. The front page is not yet, so I want to
Okay.
fix.
All right, no problem. Just all right, no problem.
Mm, okay.
Have you fixed it now?
Yeah, yes, I have. So I'll be sharing my screen again now. So are we starting straight up?
Yes, we are. Please, okay, can you put your slides up?
Yeah, it's coming on the way. Okay, it's up. Okay, then I'm coming. The slideshow. Okay. Is it good? Is it showing well on your end?
Yes, it is. It is showing.
Okay.
Okay, good day, everyone. Good afternoon, and I hope we've been having a great data fest so far. So this is our last session for today in this room 5, and Sarah Akojenu would be taking us on this session. So Sarah, you can start now.
Okay, so good afternoon, everyone. Good morning, good evening, depending on where you're joining us from. My name is Sarah Kojenu, and I'm a geospatial data scientist, and I welcome you all to this workshop on utilizing geospatial data for effective transportation optimization. Please, at any point, if you don't understand anything, please do well to raise up your hands. My co-host in person of Esther would notify me if there's any questions, or you can also drop your questions in the comment section and she would notify me as well. So this is going to be a workshop, and this workshop is divided into two. We have the theoretical aspect and we have the hands-on aspects. So right now we are going through the theoretical part so that we have more understanding on what the subject matter is about. Thank you. So like I introduced myself earlier, my name is Sarah Akojenu, and I'm a geospatial data scientist. And I say welcome again to this session. So what we are talking about is, we're talking about how we can use geospatial data to actually optimize transportation planning. And as we know, transportation is something that is big in our city here in Lagos, for those that knows Nigeria. So you can actually apply this transportation optimization in any aspect or in any area of your choice. So this is the agenda we'll be going through. Like, I've introduced myself, then we'll be diving into what GIS is, what are the data types that we have in GIS, and why GIS in transportation. Then we'll go straight into the hands-on session. Then we have a conversation Q&A session. So, right me. Now, what is GIS? GIS is a computer system that actually allows users to capture, manipulate, analyze, and design special geographic data. So GIS stands for Geographic Information Systems, and it is the system that allows users to use computers to capture, manipulate, analyze, and design geographic data. So we have here that geographic means physical locations of the Earth's surface. That means where you are on the Earth's surface actually has a location, a coordinate. That is what geographic is. Then information, data used to represent and understand that location that you are right now. And then systems are tools that is being integrated to interpret this geographical data for better decision making. So we'll be wondering what kind of GIS data sets do we have? They are majorly classified into two, which are the vector data and the raster data. As you can see on my screen, on my right screen here, there are ways, let me say that GIS data are actually ways of representing the Earth's surface. Since I mentioned that where each of us are right now is being referenced to the Earth's surface, we have different coordinate systems. Where I am right now as a coordinate system as well. So how can we now represent this data of where you are, where I am on the real world? So if you see on the right-hand side here, we have the real world down here. And in the real world, we have rivers, which forms this pond or lake. Then we have our vegetations, which is around here. So how can we now represent this in form of GIS data? So this brings us to the types of GIS data. Now, vector data sets are data sets that that are represented in form of points, lines, and polygons. So where I am right now is a point on its own. My secondary school I attended is a point on its own, and it has its boundaries. So its boundaries is made up of different lines. So we have points, we have the point, which is the school itself, and then we have the lines, which are lines connecting 2 points together. Then we have the polygon. When lines are connecting 2 points together and they are enclosed, they are polygons. So now when we come to this right-hand side, we see that the river is being represented by a boundary here, and even the forest also has a boundary, and the river is represented as a line. So raster data are data in form of grids. They are in form of pixels, let's say pictures, but they are more than pictures. Excuse me. So if you come here, you will see here that it's actually is a representation of grids, not like normal pictures, but this one has pixels that actually reference the Earth's surface. So we can see that the pixel for river spans through here, and here. Then the pixels for forest spans through them. So now another thing, some of you might ask, what about structured data in form of Excel? Now I can regarding that, the vector data also as well can be also said as the structured data, because we need information about all these points, lines, and polygons, which the structured data also holds. So now, why are we applying GIS into transportation? Transportation is a big deal now, and a whole lot of states, a whole lot of organizations are looking at how to optimize their transportation network. So applying GIS in transportations helps us to create detailed maps that helps planners assess transportation infrastructure and identify areas for improvement. So we'll be going deep into this. Also analyze traffic patterns. There's a way we could analyze traffic patterns using integrating GIS into transportation. Then also evaluate environmental impact, and then to optimize route planning. So, a minute, please. My screen is not moving. Okay, so
do you need any help, Sarah?
not for now.
Okay.
Not for now. My screen is not moving. I'm actually trying to go back. But okay, so is there any question before we go straight into the hands-on session?
I think questions would be
Please let me stop
allowed
sharing.
by 10 minutes to the end of the session, which would be by 2:20 or 2:25 thereabout. So you can just go on.
Okay, I'm coming. Let me reshare my screen. Okay, someone is saying I should go back to the last slide. A minute, please. My network. Don't know if it's my network though. Okay. Come on, let me put it in slideshow. So do you want me to talk more about it? Okay, it's working now. Do you want me to talk more about it, or should I just go straight?
Please just go on.
Okay, so she said yes. So analyzing traffic patterns, if we can actually use GIS data, when we get different points of where there are traffic, peak travel times, accident-prone areas, congestion areas, and the likes, it actually helps us to look at, okay, where are the peak areas? If we get like you getting data sets on traffic pattern, travel patterns, and where accidents are more prone. So you can, when you visualize it, you'll be able to see where there are areas that needs more investigation or more resources. Then evaluating environmental impact. GIS can help planners to assess and minimize environmental impacts like noise quality. So there's what we call the air quality data. When you try to analyze it, you can actually see where there's more there's more concentration of bad maybe nitrogen or bad gases, then you know that yes, this place needs to be focused on. Then optimize route planning. It helps us to optimize route planning, like, okay, where is the closest place for us to actually go, the shortest path. This shortest path is what we are going to do here, so that you know the shortest path to use in your area where you are. Then it also saves, for shortest path, it saves resources, it saves you travel time, and it saves you a whole lot of stress. So let me go straight into, please. Okay, please, can you see my screen? Confirm you can see the Colab.
Yes, I can.
Okay, thank you. So now for this hands-on exercise, we'll be calculating the shortest path to optimize our transportation routes. And the first thing for us is to click. Okay, so apologies, you can actually get the link here. You can scan here, or you use this link to get the link to. Okay, let me drop it on the group chat. I've dropped the link to the Colab on the group chat, so you can follow along. So the first thing is to connect to my Google Drive, because it's a good practice to actually keep your documents arranged. Then after connecting to my Google Drive, we install our dependencies. So I tried my best to actually make this Colab notebook explanatory, but if at any point you are not able to understand something, please let me know. So we are installing Auto Tools and OSMNX, but really for this hands-on session, we are majorly making use of OSMNX. So after installing it, we also import the libraries we'll be using. We'll be using NumPy, we'll be using Pandas, and the likes, and Pico. So I tried to write what they had there. Then for this exercise, I made use of, we are going to make use of Shomolu. So what this OSMNX tool is a tool, is an OpenStreetMap. It actually is a tool that gets data from OpenStreetMap. So if you are specifying anything here, you're actually specifying it, or it's giving you a result based on what it has in its own back end on OSMNX, everything that it has on its back end. So there are sometimes where you might ask for a location that might not be well represented on OSMNX, and you might not get a good representation or a good result. Or sometimes it will say cannot be found or something. So where I'm making use of Shomolu, because Shomolu is not far from where I stay, and it's somehow okay to. So now it has brought the network map of Shomolu here, and if we try to actually view our Google Maps, you just go to Google Maps. This Google Maps. Can you see my screen? I'm on Google now.
Yes, I can see your screen.
Okay, thank you. Then you type your location. We have Shomolu, Lagos. So if you notice this, there are some red lines forming boundaries. These boundaries can be replicated or seen as the same as what we have on the screen. So you know that, okay, what you're actually having is correct or a bit correct to what already exists on ground. So now what this does is to actually bring out the whole network map of the location we identified, and this visual itself is also called a graph. And what this graph is made up of is, we know our normal graph in secondary school where we had to buy all these graph books, and in the graph books there are different grids where we have lines, points, and lines forming grids. So this is something like a representation of it. And in this representation, we have two main things here. We have the nodes and the edges. So the nodes are like fundamental points like representing different places, like different locations or different junctions. So while edges are like the connections, the connecting lines between these nodes. So if we go further, maybe another time,